All right, so here we go. Temperature varies directly as volume. So that means that varies. I'm going to have an equation of this form or an equation of this form, right? It says temperature varies directly as volume. Which one of those goes with varies directly? This one. Instead of using y's and x's though, I think I'll use the letters from my problem. Temperature varies directly as volume. So this is going to be my setup. Everybody with me so far? So let's see what it says. If the temperature is 10, the volume is 28, which means K is 10 over 28, or 5 over 14. My equation then, that started out as T equals KB, I now know what K is. So T equals 5/14 V. T equals KB, K is 5/14. Find the temperature when the volume is 50. So I just plug in 50 for V. So I have 5/14 times 50 over 1, which would reduce to 125 over 7. It was 250 over 14, but it would be 125 over 7. And you'll have a calculator, so you can type that in.
Can we leave it like that, or you want to?
No, that's perfect. That's how we want it left. That's not rounded off. That's the exact answer. All right, number 6. By the way, what would the problem say differently if I were using this basic equation right here? It would say varies inversely. It would still say varies, but it would say varies inversely, right? All right, so now we're going to consider this problem. And we're going to do 3 things. We're going to list the PRRs, possible rational roots. Who remembers how we find those? Sam?
For this one, it would be the factors of 6 plus or minus. So 6, 3, 2, 4 over the first number would be over 1.
Yep, that's it. So Sam remembers that our PRRs, Zion?
Yes.
What you doing? Okay, do you have an itch or something? Do we need to go see the nurse? Okay, well, let's focus, okay? Possible rational roots are factors of the last number, we call it the constant, over factors of the leading coefficient. So in this case, it's always plus or minus, always plus or minus, 6, 3, 2, and 1. Those are the factors of 6. Over, that number's just a 1, so it's over 1. All right, now it says, find the factors. So what do?
Test them.
We guess one, right? We just guess one. Pick a number out of the list. You know you're going to get 3 factors because it's x cubed.
1.
So let's just guess one.
3.
3. Somebody said 3, somebody else said 1. Doesn't matter. Just pick one. And divide and hope that what happens? We get a 0, right? If we do, great. If we don't, we gotta start over again. This does not look good. Can you see? I don't think that's gonna work. I might try a -3 while I got it here. That's completely up to you. Oh, that looks good. So we guessed 3. 3 didn't work. I was too lazy to erase it, so I just made it a negative, and I tried -3, and that worked. Which means, what is my factor? X plus 3 is my factor, because this is the dot. When I go to graph this thing, there's going to be a dot at -3, because it gave me a 0. Now where do I go?
Do another one.
I could, but I actually don't need to.
You plug it back.
This guy right here stands for what?
Oh,
X squared
X.
minus X minus 2?
Factor.
And that will actually factor X minus 2 plus 1. Which means my other dots on my graph go where?
2.
At 2 and at -1. So what, remember back in the beginning when we guessed? Did anybody guess 2? Because that would work. Did anybody guess -1? That would work. Those are the 3 numbers that are good guesses. Now I'm going to connect the dots. Anything squared or anything? No, so I don't have any bounces. It's a cube, which means it starts down and ends up. So starts down here, passes through, connects, passes through, connects, passes through. There it is. Easy as can be. All right, number 7, much easier problem. All you have to do is sketch number 7. It's already factored for you. So how do we start? Well, we know it's going to start down and end up. How do we know that? Odd number of x's. It's got 5 x's. 1, 2, 3, 4, 5 x's. Start down and end up. All right, what else do I need to do? It's going to have some bouncing for sure, but I can't even do all that till I do something first. What do I have to do? I got to graph my zeros. So I'm going to have a dot at 1, a dot at -3, and a dot at 2. Everybody good with that? Now everything else you said was exactly right. Some of these are going to bounce. It's going to start down. X to the 5th. Start down. Now what's it do when it hits this dot? Okay. And I need you to pay close attention to what I'm about to say. Some of you missed this on the quiz. You can't just work left to right in your problem. You have to look specifically for the parentheses that gave you this dot. Okay? It's not the first one. The parentheses that gave you that dot is right there. It is squared, so we're going to bounce. Now, the parentheses that gave you that dot is right there. It bounces. The parentheses that gave you that dot isn't squared, so it's going straight through. look at the parentheses that created the dot. That's how you know if you bounce or not. All right, let's get through one more. Here we go. Now, notice on this problem, I said factor and sketch. I didn't ask you for the PRRs. Now, you can do the PRRs if you want to do it that way. But what do you notice about this problem? It factors by grouping. So if you notice that, then factor it by grouping if you want to. If you want to do PRRs and guess, that's your choice. That will work too. There would be a lot of PRRs for this problem. So I'm going to just group it. So I'll take an x squared out. And what can I take out of these? Negative 9, leaving me with x plus 4. Remember what we talked about? This is what has to happen, right? So we have our x plus 4. And then what else do we have? X squared minus 9, which is x plus 3x minus 3. Now we're going to sketch it. So where do our dots go? Negative 4, negative 3, and 3. Odd starts down. Nobody bounces. So we just connect through the dots, and there we go.
Just like that?
Just like that. Math week in the morning. Do not forget. Do not forget.